Well, a very good morning to you from Mission Control Houston. An early good morning as we bring you now our live coverage of the installation of the Bigelow Expandable Activity Module, referred to as BEAM, here live on NASA TV. You're now joining us inside of the International Space Station Flight Control Room, where the teams have been overseeing the operation over the last several hours. And we are now just within the hour away from the newest addition to the International Space Station being installed in place. We'll get video back in just a couple of minutes, but BEAM itself right now sits just inches away from its berthing point on the aft port of the Tranquility module. And again, just within the hour, expecting that to be attached to the International Space Station. Going around the room real quick, just so you get an idea of who's interacting today. The team is led by Flight Director Amit Kshatriya, and at the Capcom position right next to him, Rebecca Wingfield, going to be talking to the crew on board the station. And then one other major player inside the room, Laura Luce, robotics officer, or Robo, and she's going to be driving the beam module in the final few inches to that berthing point just a few minutes from now. As you can see, we are getting some live views now from the International Space Station. BEAM, again, the Bigelow Expandable Activity Module, the first human-rated expandable module to be ever launched into space, and it's going to be spending 2 years attached to the International Space Station for some periodic testing. This is a live view from a camera on the robotic arm looking at BEAM just inches away now from the aft docking port on the Tranquility module, also known as Node 3. Just for a brief history of how we arrived at this point, BEAM launched on board SpaceX 8, the SpaceX Dragon unmanned commercial resupply cargo craft back on April 8th. The vehicle launching atop a Falcon 9 rocket from the Cape Canaveral Air Force Station in Florida. The launch successful, putting Dragon into orbit just minutes after that liftoff on a clear Friday afternoon. Dragon then arrived at the station back on April 10th and was grappled by the station's Canadarm2 robotic arm, which is now being used in all of these BEAM activities this morning. That grapple being done by European astronaut Tim Peake from inside the cupola workstation. He was backed up by NASA astronaut Jeff Williams, who's going to have a hand in attaching BEAM today, as he'll be managing the common berthing mechanism where BEAM is going to be attached just within the hour or so from now. But again, that grapple with SpaceX happening back on April 10th. Earlier this morning, of course, though, the operation to extract BEAM from Dragon's trunk, where Dragon commonly carries unpressurized cargo, different payloads attached to the outside of the International Space Station, took place. This extraction beginning at right around 1:20 a.m. Central Time, 2:20 a.m. Eastern Time, with the Canadarm2 grappling on to the Bigelow Expandable Activity Module and beginning to slowly extract it. This was done first by releasing 2 sets of latches that were holding BEAM in place to Dragon's trunk. First set released, the arm then grappled, then the second set released, and then the arm slowly backed it away. And then over the last several hours, robotics controllers down here on the ground, Laura Lucier, the robo inside Mission Control Houston today, have been maneuvering the arm into its eventual install point. But again, all of this kicking off earlier this morning, the first latches, or the second set of latches, opening at 12:58 a.m. Central, and then that extraction happening at 1:20 a.m. And that brings us to where we are right now. BEAM, again, just inches away from the aft port of the Tranquility module, where it is going to be attached for the next 2 years. During that time, crew members will enter BEAM periodically to take various measurements and monitor the performance of the module. This, again, the first ever human-rated expandable structure to be launched into space. And Expandables, something that is on the list of potential technologies that NASA is investigating for future long-duration missions well beyond low Earth orbit and eventually on the journey to Mars. which is filled with a lot of complex challenges that NASA and all of its partners, both international and in industry, are continuously working to solve. The International Space Station serving as that proving ground, if you will, for a lot of this technology, and being just one of the latest. NASA's interested in these expandable habitats as a potential concept for the habitat structures for cislunar space, so the area between Earth and the Moon, and then also even beyond, even looking at these for surface habitation, so surface habitats for eventual crew members to live on once we do put boots down on Mars. And so a successful demonstration of beam on the International Space Station will be a big stepping stone to understanding the role of expandables and what they could have for future space habitats. Just some of the advantages of expandables, to give you a brief overview, much lighter than traditional hard shell. These aluminum modules that the International Space Station is comprised of, and also much more compact upon launch, and that's where some of the real cost savings can come in. If you can not necessarily decrease the weight, but decrease or increase the density of these payloads when they're launched, and you can pack more of them into one rocket. You can decrease the amount of launches to get all of your stuff, all of your habitats, all of your equipment into orbit, and then decrease the overall cost of missions. So definitely a technology with a lot of potential for future exploration and getting tested out now on the International Space Station. This view that we'll see a couple of times, this is a camera actually set up on the inside of the International Space Station, set up by crew member Jeff Williams. This is what's known as the Centerline berthing camera, looking right out of the common berthing mechanism at the aft port, so that view straight into beam right now, where you can see everything pretty lined up as beam. Again, just a couple of inches away from the docking port, where we should see it attached within the next hour or so. Once the robotics officer drives beam in, the last short distance, it'll be in what's known as RTL, or the ready to latch position. And then at that point, Jeff Williams will get the go-ahead to begin operations with the common berthing mechanism. You might hear it referred to on space-to-ground conversations as the CBM. The first stage capture initiates a series of latches to put an initial hold in place on beam, and then 16 bolts will then be engaged for the second stage capture, and that'll be the hard mate, and that will be when beam is officially attached to the International Space Station. And the robotics officer here in Houston, Laura Lucier, just giving the flight director a quick update. All of their alignments looking good. Coming up very soon will be the commands to begin driving beam in. The sun is going to be setting soon, so the view won't be quite as pretty over the next 45 to 50 minutes or so, but getting closer again to that installation. It was originally slated to take place at about 5:15 a.m. Central Time. The team running a little bit ahead of schedule. That's why we went on the air here on NASA TV 30 minutes early, but everything looking good so far. Not tracking any issues with the operation so far. The robotic arm performing flawlessly, and beam itself just a short distance away from its port, where it will reside for the next 2 years. Again, as mentioned, a lot of differences between these expandable structures and the more traditional hard shell metals. Just to give you an idea, beam, of course, a technology demonstration, it's much smaller in scale than all of the other modules on board the International Space Station. It has no power inside, no lighting, therefore, so anytime the Astronauts will be going in, again, 3 to 4 times a year for several hours to collect various sensors that are taking temperature data, radiation data, and then also tracking any potential debris impacts. It'll be dark inside. Some of the flight control team likening it to spelunking, going into a cave, if you will. But the astronauts themselves, of course, very excited to test out this new technology. Beam, once it's expanded, so that not happening today, that will happen a little bit later on in the end of May, after there's plenty of time for leak checks and other checkouts before the actual expansion begins. And here you can see Beam beginning to close that distance in. But the expandable module, once it's fully expanded, will have roughly the same amount of cubic volume as a small bedroom. It'll have a cubic volume of 565 cubic feet, weighing in at just a little over 3,100 pounds. To give you an idea of size, the module that it's attaching to, Tranquility, has an internal volume of over 2,400 cubic feet, so almost 5 times the size internally. But Beam definitely looking forward to the expansion, but the installation moving forward smoothly today. And again, the next major milestone is going to be getting Beam into that position, what's known as RTL, or the ready to latch, at which point we'll begin to look to the common berthing mechanism operations being done by Jeff Williams, who will be standing by inside.
Station Houston, Space to Ground 2, a status for Jeff. We're pushing into RTL.
And you just heard the Capcom Rebecca Wingfield give Jeff Williams, the NASA astronaut, one of the NASA astronauts on board, a heads up. They're going to be pressing in now to that RTL position, that ready to latch position, getting Beam ready for first stage capture, at which point Williams will drive a series of latches on the common berthing mechanism from inside Tranquility to put that initial capture on the Beam module, and then that'll set it up for a second stage capture, which involves 16 bolts being engaged to hold the module in place.
And go ahead with the status.
Hey, Tim was just trying to get the word to Jeff that we're pushing into RTLs.
Copy that.
And you can see the sun beginning to set as Beam continues to close in. The robotic arm, Canadarm2, closing the distance between the module and the common berthing mechanism port on the aft part of Tranquility. And getting some light still shed on beam and Canadarm2. The station itself right now flying over the northern Pacific as they are headed into an orbital nighttime, just about 252 statute miles over the ocean. Again, moving into that RTL, that ready to latch position, and that'll be more or less the final maneuver for the Canadarm2 to install beam, at which point everything will transition over to Jeff Williams on board. He'll be doing the first and second stage captures. We'll consider it officially installed once second stage capture is complete, when those 16 bolts are engaged and beam is held in place. Again, this is just the first of two major operations to get beam ready for the crew members to go in it for the first time. The installation taking place today, and then the eventual expansion taking place several weeks from now. That'll be happening at the latter part of May, when beam is expanded by the crew members on board. And again, the crew members expected to go inside of beam 3 to 4 times a year, and for its expected 2-year attached phase to the International Space Station, in order to collect data from a variety of sensors that will be inside. Also doing things like surface sampling and changing out some of those different monitors, looking for things like radiation exposure inside of the module, also temperature changes, how the modules basically faring in that space flight environment. Also looking for any impact detection. Beam providing similar protection from what's known as MMOD, micrometeoroid and orbital debris, as the other International Space Station modules. As it is smaller compared to the other modules, the risk is actually typically less. Also, just important to note that the station's been in orbit for 17 years now, with humans for over 15 years, and no MMOD strike has ever required isolation of an existing module. And beam and expandable, not having that hard shell, the shielding consisting of multiple layers of fabric, with an internal restraint and bladder system. And beam specifically designed and tested to leak rather than burst. People commonly hear expandables and get the idea of a balloon, but very important to note that beam does have an internal structure still, so it is much more robust than you might imagine. Again, having all of the same safety, meeting the same safety restrictions and more as our traditional metallic modules. And hearing good news from the robotics officer, Laura Lucier, should get a call from Capcom momentarily. Looking like beam now in that ready to latch
Station
position.
Houston, Space to Ground 2 for Jeff. Maneuver to RTL complete. Go for first stage capture.
We go for capture, and I do have 4 RTLs.
Excellent read back.
So again, we are in that RTL position now, that ready to latch position, that happening at about 4:20 a.m. Central Time. At this point now, the work being handed over to NASA astronaut Jeff Williams, who's inside of the Tranquility module. He's going to be doing the capture operations now with the common berthing mechanism. That first stage capture will engage a series of latches to put an initial hold onto beam, and then he'll be able to, once that's all confirmed, be able to do the second stage capture, driving the 16 bolts and getting it in place.
Houston, first step 3, checking to first stable attitude control configuration, confirming resting segments are disabled.
And Jeff, step 3 complete. You go for step 4.
The 4 in work.
So again, right now on board the space station, Jeff Williams. Jeff Williams conducting that first stage capture execution to get beam in place on the aft port of Tranquility.
Houston Station, first step 4, go for SSRMS mode to limp.
Houston copies in work. Station Houston on 2, SSRMS mode to limp complete. Go for second stage capture.
And
The incremental capture
so,
to 130 is in work.
Houston copies.
so at this point, first stage capture has been completed. Those initial latches in place. Now, Jeff Williams working on second stage capture, getting ready to drive the series of 16 bolts that will secure beam in place for its spot for the next 2 years. Again, everything moving well ahead of schedule this morning. We're about 50 minutes ahead of where we thought we would be per the timelines. The robotics controller moving through all of the motions very quickly, officially no issues with the arm. And now Jeff Williams getting the beam module bolted into place.
And Houston Station, there was no response to that capture to 130 degrees on the PCS.
Checking. Okay, Jeff, we copy that you sent the capture to 130 command. Next, you need to send the yes execute.
I understand.
And so the capture right now being done in an incremental fashion.
Copy that. Following along.
Everything continuing to go smoothly with the common berthing mechanism operation. Again, first stage capture already complete. Just minutes away now from the completion of second stage capture and the completion of our installation of the Bigelow Expandable Activity Module to the International Space Station.
And no response to that command. Should I repeat it?
Checking. All right, Jeff, before you do the repeat, we just want to confirm you sent the capture to 70 degrees command.
Affirmative.
Okay, Jeff, we're go for you to try that command again. Capture to 70 degrees, execute.
I need a yes though, right?
And Jeff, the full sequence is capture to 70 degrees, execute, yes, execute.
Okay, I did capture to 70 degrees, execute, and I got the pop-up command verification, which is an OK or cancel.
Checking. All right, Jeff, so that is an expected config. You got the OK because it's a guarded command, so go ahead and select OK, and then you should hit the yes execute.
Copy. Okay, it's in progress.
Houston copies.
And I've got latch 3 at 73 degrees. The other latches are all 69.
We see it also, checking.
So the team looking at a quick data point with one of the latches driving a little bit beyond the angle expected, or beneath the angle expected. So they'll take a quick look and get words back to Jeff Williams momentarily, but again, continuing to drive forward towards second stage capture, which is going to be the final confirmation that beam is attached.
And station back with you on 2. Jeff, we'd like for you to repeat step 5.3 as written, please, to get latch 3 in family with the others.
Welcome. And that's complete, and they're all 69 now.
We see the same. Go to press with step 5.4.
And so all the latches now cooperating, continuing to drive in. Just one more latch sequence to go, and then they'll just be about in the position to begin the bolt acquisition. Again, 16 bolts. I'm going to be driving in to hold beam in place where it's going to reside for the next 2 years. The Bigelow Expandable Activity Module almost done attaching to the International Space Station. Jeff Williams inside of Tranquility working with the common berthing mechanism. Everything progressing pretty smoothly so far this morning. Again, pretty far ahead of schedule with all of the robotics operations being done very quickly. But beam right now, first stage capture has been complete.
Moving on to step 6.
Houston concurs.
And just now getting confirmation, second stage capture has been completed, and that coming at 4:36 a.m. Central Time, 5:36 a.m. Eastern Time, while the station was about 255 statute miles over the southern Pacific Ocean. So while Jeff Williams is inside one of his fellow crew members, NASA astronaut Tim Coper, the Expedition 47 commander, already shared this image of the operations where he got a pretty fantastic shot of beam after it had been extracted from Dragon's trunk. You can see it attached there to the end of the Canadarm2 robotic arm. Beam now attached successfully to the Tranquility module. The newest addition to the International Space Station and the first human-rated expandable module ever to be flown in space. So again, beam now attached to the International Space Station. That second stage capture coming at second stage capture coming at 4:36 a.m. Central Time, 5:36 a.m. Eastern. While the station itself was flying over the southern Pacific Ocean. Again, beam is going to be attached over the next 2 years. The crew members going in periodically, 3 to 4 times a year to take a variety of data samples from sensors that are going to be residing inside of the module. So with beam now attached, all eyes are going to be looking forward to the next major operation, the next major step in its utilization, and that's going to be the eventual expansion, and that's currently targeted to take place in late May. That's going to be preceded by a lot of crew time to do what's known as vestibule checkouts, a number of leak checks, and other outfitting in order to actually expand the module. Once that does come, though, the crew will first introduce a small amount of air from the station itself to give beam its initial shape. And again, as you can see from that quick animation, there's a number of possible expansion scenarios. After that small amount of air is introduced from the station, they'll then do just some quick leak checks again, just to make sure everything good with the module itself. Also to make sure it's got the right shape once it's done expanding, and then it'll be time to activate the internal air source inside a beam. It has a number of air canisters inside that will fully inflate it, expected to be fully inflated at roughly the same pressure. There's a small range of acceptable pressures for a beam to be expanded to and pressurized to, but expected to equalize right around the 14.7 psi that the International Space Station is kept at. That, of course, the same atmospheric pressure at sea level down here on Earth that all of us enjoy. So that will be a very exciting moment, again, when that first expansion takes place. Following the expansion, it'll be about a week or so before the crew members first go in. So again, the hatch between beam and Tranquility is going to remain closed over the next several weeks, and will also commonly remain closed whenever the crew is not inside gathering the sensors that are monitoring things like the radiation and temperature. But once the eventual first ingress, so the first chance the crew members get to go inside of the Bigelow Expandable Activity Module, we'll definitely be looking forward to that as well.
And Houston, while I have you, I'm not going to jump into it just right at the moment, but are there any time constraints on the next activities, or can I perform them anytime? That is the CBCS camera removal and the latch operation.
And Jeff, we're putting the CVIU safing in place right now, so if you'd like, I can let you know when that's complete, and you can get into that at any point after that.
Okay, very good. Thank you.
And so soon the robotic arm will be backing away from beam as it is again successfully attached. That second stage capture coming at 4:36 a.m. Central Time this morning. Jeff Williams executing all of the commands on the common berthing mechanism and getting beam securely in place. We'll stick around for a couple more minutes as the sun should be shining in the next 5 minutes or so.
For Jeff, the CVIU is safe, so you can get into the CBCS teardown at any time. And once that's complete, you're go for hatch to latch.
Station copies. Thank you.
But with beam successfully attached, the module, of course, still in its packed formation, so measuring in at about 7 feet in length and just a shade under 8 feet in diameter right now. Once that expansion does occur in late May, though, it'll It'll expand out to a length of just a little over 13 feet with a diameter of 10.5 feet. It'll have an interior volume of 565 cubic feet, so just about the size of a small bedroom. Again, just to give you an idea of relative size of the Tranquility module that it's attached to, it houses things like one of the 2 toilets on board the International Space Station, as well as exercise equipment for the crew members. Has an interior volume of about 2,400 cubic feet, so beam a little bit smaller than its attached or the hard shell structures that it's attached to, but beam, of course, a very important technology demonstration. The first human-rated expandable structure to be flown into space, and now firmly attached to a giant spacecraft with humans on board. So a very important milestone, a very exciting milestone, and everything going to be looking forward to that eventual expansion. And again, beam expected to be attached for a period of 2 years. Those tests coming roughly 3 to 4 times across the year, where the crew members will go inside to gather the sensors that will be arrayed throughout beam, and then downlink that data back down here on the ground. The crew members will be collecting that. There's no internal power in beam, so all of those sensors running on various batteries and things of that nature. But again, the expansion targeted to happen at the end of May. It'll be a 2-phase or a hybrid approach, if you will, with air first being introduced from the International Space Station's atmosphere itself, and then canisters that were flown up inside of beam with atmosphere will then be engaged to finish the expansion of the module. Beam, at the end of its life, will be jettisoned with the help of the International Space Station's robotic arm. It'll grapple beam and point it to the most nadir or Earth-facing, essentially, position, and then release the payload with 0 push. It's expected to follow a trajectory that will cause it to burn up as it re-enters the Earth's atmosphere in less than a year. And this will be the first time that station has jettisoned an object as large as beam, rather than returning it to Earth in a cargo vehicle like we did back with the space shuttle. But again, this is a very important technology demonstration happening on board the International Space Station, where we're testing a number of technologies that are going to be necessary for all of the future exploration missions that we're looking forward to, whether it's cislunar, commonly referred to as the proving ground, where the space between here and the moon and slightly beyond, where we'll learn all of the practices necessary for living and working in deep space, but then also definitely looking forward to the first trips to Mars. Expandables being investigated as one of the potential capabilities for use of crew habitation, both in the in-space portion and on the surface for eventual missions. Also, other things being looked at with Expandables is their potential for commercial space stations. Beam, of course, built by the Bigelow Expandable, or the Bigelow Aerospace. Being developed as a cost-sharing partnership between NASA and Bigelow, with Bigelow leveraging technology that NASA conceived back in the 1990s and then licensed to the company. So each, both NASA and Bigelow, benefiting from the sharing of expertise, costs, and risk to pursue these mutual goals. And there we get sunlight coming up. You can see beam there attached to the Tranquility module. Again, the robotic arm still attached. It should be backing away in just a little bit. But beam successfully attached. That second stage capture coming at 4:36 a.m. Central Time, 5:36 a.m. Eastern. So as we get one last look at beam, again, you can see attached now to the International Space Station, the module still packed, measuring in at 7 feet in length and just under 8 feet in diameter. We're, of course, going to be looking forward to the expansion coming up in May, where it'll expand out to a length of 13 feet and a diameter of about 10 and a half feet. We'll, of course, update you on those dates in the coming weeks through nasa.gov and on our social media as we continue to firm up when that expansion will actually take place. But everything being done successfully this morning, well ahead of schedule. Again, the second stage capture coming at 4:36 a.m. Central, 5:36 a.m. Eastern, while the station was flying over the Southern Pacific. One quick programming note for you as we get into the end of this morning's coverage. There will be a in-flight event with Jeff Williams, the NASA astronaut who was responsible for doing all of that work to do the final capture of beam. That'll be at 11:35 a.m. Central Time, 12:35 p.m. Eastern Time, where he'll be speaking with folks down at the U.S. Science and Engineering Festival up in Washington, D.C. So stick around a couple hours from now and be sure to check that out. We'll take one last look at beam. You can see the station's robotic arm now backing away as it successfully transferred the expandable module from the trunk of the Dragon spacecraft over to its new home on the aft port of the Tranquility module, where it's going to be attached for the next 2 years for a very important technology demonstration, the first human-rated expandable structure to be flown in space, now attached to the International Space Station. With that, we will go ahead and wrap up this morning's coverage. Thanks for staying up or waking up early to join us for this pretty important milestone, and we'll look forward to the next and continue to bring you live coverage here on NASA TV. For now, though, we will go ahead and sign off. This is Mission Control Houston.